please, you are familiar with this. We have to change yield point and plastic viscosity every day based on mud engineer report. So this is painful and this is useful for calculating hydraulics parameter, mud rheology. Okay, so this to be updated day by day. I know there is some clients not giving importance for hydraulics. But some clients needs this real-time hydraulics to be adjusted. Okay, so changing these parameters, also controlling these hydraulic horsepower and jet impact force, affected too much with PVYB. Okay, so if the client is interested, or if the company is interested to know what about these important parameters, is it going okay or less? So we have to update day by day PVYB. Okay, so this is easy. We can just enter PVYB inside and please choose your method here. But sometimes when you have direction drilling, because maybe someone will ask you. Also in DTCS is same. All software of mud logging is same. Sometimes if you have direction drilling and they have auto track RSS direction assembly, they measure ECD on bottom. And usually the measured actual ECD on bottom is different or more than your calculated ECD. This ECD. Why? You have to have answer for this. This ECD. Okay? Because the direction tools measuring ECD corresponding to 1 point. So if you have different sizes of drill coolers, okay? If you have different sizes in drill coolers, it will be different than the measure, because your software taking average annular volume for the BHA. So it gives, if you have some drill cooler big, some drill cooler small, so it gives average ECD. Calculated ECD differs than measured ECD. And of course, the method itself, when you choose each method, gives you different ECDs, because it's depending on how is the hydraulic model you are using. These 3 hydraulics model or 4, a little bit different to each other, and you use it in some situation. For example, if you are working with turbulent flow and on the surface section, yes, it's better to work with Bingham. But based on my experience, always we make modified power law, which is most suitable and give you the nearest ECD actual. Okay, so I recommend to put modified power law all the way. Okay, so modified power law all the way. So what if the client asks you, please adjust the ECD to be same like? What to do? It's calculated and he is measuring. So calculated should be different than measuring. Only just you increase, play with these 2 numbers. Okay? It will adjust ECD up and down. So he just told you that ECD is 1.5 and your ECD calculated 1.3. So increase PVYB till it comes to this. Because the PVYB coming from mud engineer report is based on surface test, without big solids, okay, without cuttings. But measurement of ECD inside downhole, it's containing also cuttings and not only mud, okay. So if you ask it to adjust ECD, play with these numbers, BVYB. Okay. So you have two options. Eitherwise you put mud yield point and plastic viscosity, or you put the CETA. This also it's in mud engineering report. It's there. It will give you these results because BVYB is calculated from this CETA, different CETA. Okay? You just enter manual of this viscometer parameter. Okay. So if you put it here, it will give you the same line. But easy, just to make this and get from mud engineering report. No need to put CETA. Okay. Here, in these three items, we have one way. Of course, if you have sensor, this is easy, will be hidden. Okay? No need. Because you have sensor, this automatically change. But normal situation, mostly we don't work with mud weight because you need to clean water, clean. If you leave mud weight for 2-3 days, some cutting will accumulate. It will give not good values for sensor. If you work with mud weight sensor, you have to clean it regularly. If you not restore it, you just put it manually and get it from mud engineering report. Pressure loss for MWD and mud motor, this is very important because it's affecting the total pressure loss here. What is the total pressure loss here? You see, this is green. I have something called surface pressure loss, annular pressure loss, there is string pressure loss, big pressure loss, total pressure loss. Okay? What is the meaning pressure loss? Pressure loss not meaning pressure drop. No. Pressure loss is total pressure loss should be theoretical pressure based on based on the drill string geometry and well geometry you provide. It means your question yesterday, I'm making hydraulic report, okay, to know how much standby pressure may come in this run. If I use this nozzle of bed, if I use specific flow rate, how much pressure, theoretical pressure. So total pressure loss is theoretical pressure inside the whole system, which should be nearby standby pressure. Okay, not far away. Okay, because if standby pressure is very far away from this, there is a problem inside. Okay, because the actual should be nearby the theoretical. So what if this number getting more than this number by 700 bar or 200 bars or something? So it should be a problem. You have to check and you have to inform. Also, if they ask you hydraulics and you go to reality, you found a big difference between standby pressure and total pressure loss, it means that maybe one nozzle black. That's why this pressure getting hard. Because software, you didn't inform software, this is one nozzle black. Maybe one nozzle or two nozzles falling down. So the jets of bed is bigger. So in reality, it will be less than theoretical. Yeah? So this number, okay, affected mainly with these nozzles. If one of these nozzles are plugged because of LCM, because of any cuttings, because of what, your standby pressure will be higher than the theoretical. So you have to clarify, you have to inform. I have a big difference between actual pressure and theoretical pressure. In this system, why I am saying this? In this system, you are also, if you are using mud motor and LWD, you know, if you insert mud motor and LWD to the string, it's affecting the pressure because it's from inside. It's narrow, not 2.8 same like drain cooler. It's giving narrowing, okay, tightening, so that the pressure when you go through MWD and through conventional mud motor, it's getting hard. So you have to ask direction. What is the pressure drop in your tool? It means how much pressure should be added theoretically when I am using your tool. He will tell you like, okay, 200 bar for MWD and motor. Okay, no need to ask him what for motor only, and what for MWD. If he told you this total pressure drop is 200 bar, okay, put here 100, put here 100. Then this will be taken in consideration for the calculation to total pressures. Okay? You can discuss if somebody not understand. Again, I see. Okay?
Cái này có nghĩa là nó thôi để Trung nói đi, Trung nói đi.
Tức là trong cái tool, nếu mà trong trường hợp không có tool FWD map motor thì không cần bút nữa. Nhưng mà khi mà có hai cái đấy là mình phải đưa cái total pressure load của hai cái tool đấy vào cái hai cái MU đấy để nó tính toán cái SCB đúng và cái total pressure load đúng. Nếu đưa vào thì sẽ có sự chênh lệch giữa hai đấy. Thì ra tư bản mới nhìn cái đấy. Cái tin rằng tư bản nó cần comment nó cần.
Hoặc là lúc mà cần nó tính toán ECD nó chính xác, hoặc là nó sẽ
ECD
khớp
với
với
cái chính xác là phải đưa tất cả các thông số vào.
cái
Đấy thì bọn
đúng rồi, cái đó là nó sẽ phải cung cấp cho mình.
Sẽ phải mình hỏi nó cung cấp cho mình. Những cái tool của nó đều có cái passport, đều có cái
những thông số nhiều như gì. Cái phương pháp thì chọn thế nào?
Phương pháp thì nó khuyến cáo là sử dụng cái modify.
trong kinh nghiệm của nó dùng
Nó
cái
kinh
đấy
nghiệm
là sát
của nó sát
với thực tế nhất.
Theo kinh nghiệm của nó chắc tới lý là nó làm theo kiểu tỉ trọng của nó là chỉ độ thấp, nó hoàn toàn trên yêu xe một điều, nó không phải sâu hơn nữa. Chứ nếu mà nó phải tỉ trọng cao như 1.5 trở lên ấy, thì mình chưa hiểu phương pháp trong này. Nhưng mà như của ADS ấy là từ 1.5 đổ lên là nếu mà không chọn đúng phương pháp đấy thì nó sẽ khác nhau rất là nhiều.
Đấy nó còn hướng dẫn luôn.
Chỉ là bảo ở đây nó cũng có phương pháp này nó cũng giống nhau. Power này chính là cái ốt tác của nó. Bước đi ngang cấp xuống cấp lên cái câu hỏi này mình chưa hiểu hết các
Cái bảng này là bảo
Đúng là hai cái mít đó là khi anh em mà tính chọn phương pháp nào hợp lý với cái áp suất bơm là được thì thôi, chứ còn tất cả thông số anh em không còn cho được hết đâu. Giống như hydraulic ở bên hệ thống của mình đó, là cứ chọn phương pháp nào mà cái total pressure của mình đó nó gần bằng xem với cái áp suất bơm là được không, chứ đừng có tại vì mình không còn cho được hết. Đúng rồi, xem cái áp suất bơm của mình đó.
Khi đó nó tính toán ra nó phải gần bằng cái áp suất bơm. Nếu mà nó chênh lệch quá nhiều, cái áp suất bơm lúc đó nó chênh lệch với cái áp suất tính đấy thì có nghĩa là một là cái lỗ thủy lực nó bị bịt hoặc cái gì đấy nó sẽ gây vấn đề. Thì nếu mà cho nên nếu mà có hai cái này đang sử dụng thì nó khuyến cáo là nên đưa vào, tại vì cái kia nó có một cái vòng siết đai siết nó sẽ hiểu nhầm sau cái này nó sẽ tính hiểu nhầm sau với lại cái việc mà cái lỗ thủy lực nó bị bít đấy. Okay.
Clear, yeah? Clear.
Cái phương pháp tính
I have a solution I want to add. In our work, mud density maybe come to 1.8 and more. Mud weight very high. Mud weight. So to the remote
More what?
logical mode.
If we use the mud weight very high, this this is where not good, but
Working also.
okay.
Working also.
Yes.
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 Ồ.
Có thể nó
Cái đấy
là
là
cái vẫn
nó
cao
cũng
rồi.
lên được
Thì cái
cao.
phương pháp này nó vẫn đúng
Ừ.
và gần nhất so với những thằng khác. Ok. Ok.
I tried many times with 16 BBG. What's 16 BBG? 16 BBG.
Dạ đúng.
16 EPG là bao nhiêu?
16
1.9.
Ok. Ok.
1.9 gram per cubic centimeter was fine. Okay. I worked with 1.9 gram per cubic centimeter.
Yeah.
It was same. It was good hydraulics. It's based on modified power law. Working guaranteed. Okay. So now we know the function of this. We get this data from direction driller.
Yes.
Okay, and all hydraulics will be good, including system pressure loss, because sometimes we need this data for evaluating the mud behavior inside, because mud rheology is very critical in deep wells. So they are looking for hydraulics, they are looking for impact force, looking for HSI, which is hydraulic impact force, and hydraulic horsepower. These parameters are important in deep wells. I know there is for a rig manager, he have his own software, maybe. Okay, he put the data inside his own software, he can evaluate. But you have the ability also to help him from hydraulics. You offer to him, here is hydraulics screen, real time, meter by meter. You can monitor, please. You can see what is impact force, what is hydraulic horsepower, while changing different flow rate. Because this affecting also ROB. Good rheology and good hydraulics helping for ROB, better ROB. Okay? Not all the problem coming from hard formation. No. Hydraulics, nozzle optimization, flow rate optimization, this stuff helping very much for rate of penetration and making progress. Okay, so it's useful to offer this to rig manager, and it's working very nice. Okay, the last thing here is it's also depending, it's also related to hydraulics for the surface equipment. Okay, we have different type of surface equipment. This table is important for one thing, only one thing, which is this surface pressure loss. It means the division of from the total pressure which applied on the hose, mud hose, top drive, standby pressure line to the pump. How many pressure part inside this? So this table is only useful for total pressure drop and surface pressure loss. So if someone comment and he told you your surface pressure loss is very high, then my pressure loss as a rig manager, please change the case, because this is the standby line, hose, swivel, Kelly, diameter, specification, okay, to adapt the surface pressure loss, which is this one. And if you don't find, if you communicated with Toll Pusher and don't find the numbers he have coming critical like this, you can put customized one. Okay, you can enter here the data from Toll Pusher. Then surface pressure loss would be equal to him, to be all in one page. This only is a benefit from this table. So if somebody asks you, what is this table, you can tell him why it's useful only for them. Okay? This for hydraulics. Torque and drag module is something advanced a little bit. Okay? This is calculating based on bearing parameters, axial load, torque and restraint, torsional vibration, some advanced stuff, okay, which is mainly also calculated from direction driller software. He can know stick slip, torque drag. These parameters is useful for keeping his tools in a good way, no twist off, no vibration on the tool. This is to control the vibration of the tool, monitor vibration, lateral vibration, axial vibration. It's a little bit advanced. For mud logging, not common used, but it's here as option. Okay? And me, I didn't work with because it's not requested. But if requested, yes, you have some data you can offer to them. All is computed parameters. Okay? So it's there if you need. Okay? If no need, because mainly who is doing this job, torque and drag, direction company. Direction. Okay? Of course, this is a good function, that kill sheet, that you can identify in well-controlled situation to the client what is the specification of the influx. Okay? If you have gain, 5 barrel gain, actual gain, 10 cubic meter gain, and they are closing POB, they have shut in drill pipe, they have shut in casing pressure, they have this measurement, so it means that formation is producing gases, okay, which is pushing mud to be out. That's why you got increased volume in system, okay? So you can participate because you are a part from the rig. You can participate with rig to evaluate what is the well control situation. And you also can initially identify what is the type of this influx. Is it water? Is it gas? It is here somewhere. Type. Estimated influx type. Is it water, gas, or is it what? So we can practice now. I will do one example. But first, before, you have to record daily the SCR, slow circulation rate, which the rig is making every day at midnight between changing the handover, the shifts. They make something called pump circulation rate. SCR, you know SCR? Slow circulation rate. Slow circulation rate. What is the slow circulation rate? Okay, at midnight before changing drillers, okay, or it's commonly happening, they open, no drilling, they pick up after connection, okay, normal situation, no gain, no loss, everything is fine, they open pump 30 stroke. Then they measure standby corresponding to 30. Okay, so maybe 300 bar, maybe 50 bar, and he just make 40 stroke per minute. So he record pressure according to 40, corresponding to 40. Okay, and measuring at 50. I will show you example here. Okay, because this SCR important in kill sheet. Okay, slow circulation rate. This is every day be done, and they give to rig manager. So you cannot make well control evaluation unless you have SCR. Why is this SCR is available? Is important because it's like a kind of calibration, kind of reference. It means that in the normal condition, 30 strokes gives 50 bar, normal condition. But if I have gain, okay, and I have not good situation, he also open 30 strokes, he will have, for reality, if you have kick from formation, you have 56, 57 bars. Okay, so this is away from normal condition. So the difference in pressure, it goes to this calculation, and he can know how much critical the situation. Okay? This is something in drilling engineering also is adding good value to you. Here, I'll show you one example. Also, if you have the old distribution kit, there is a different software called kick control. Kick control.
Cái đó chưa.
Same thing, kick control, like hydraulics.
Yeah.
Okay? Here's well.
Bên mình không xài mấy cái đấy. Có cái này không xài.
Desktop with pressure. You have the software, so you have to know all features. Not recorded here. Usually, we are recording here, the SCCR, but it seems in this well they didn't make. It's coming like this, 30, 50 bar, okay, 40 strokes, 55, 50 strokes, okay, 60, okay. This information is important in here, okay. Here is SCCR, okay, stroke per minute. So we will make example now. Okay, initial mud weight. I am working with mud weight 1.5. The total depth is known. The kissing shoe is 3500. So if someone asks you to make a kill sheet, okay, so you have to get SCCR. Tell him I need SCCR. Okay. At stroke per minute 30, it gives, for example, 50. At 40, it gives, this is the stroke per minute in the normal situation. 50, it gives 60. Okay? Kill stroke per minute, that means what the rate I'm switching on the pump to get rid of this kick. So he was the driller working with 60. For example, okay, and last leak of test. We know leak of test, okay, but he needs not mud weight, he needs bar. So last leak of test at kissing shoe, for example, 350 bar, okay. Then if the driller have shut in drill pipe, because we close the annulus, okay, shut in drill pipe. It will be in your screen on here. Okay? Shut-in casing pressure, it will be in your screen here. So you will find in this situation no bump, they switch it off bump. Okay? And top drive is steady, then this become higher, this become higher. Now you know that we have a critical situation in the rig. So we have shut and drill pipe, we have shut and piece integration. Based on these numbers, you take, you put it here, okay? Suppose that this is 100 and this is 0, maybe this is 50, okay? Of course, last yield point, okay? And how much I gain at the tank, like 18 cubics, and what is the total, okay? Active volume, which is maybe 500 cubic meter, then this only the input and the rest is the output. So this is very important. It just estimate you have to increase your mud weight from 1.5 to 1.8 to get rid of this one. But it depends really on this. So if you have here like 600, you have here 0, everything will be changing. Okay, it's 1.5. The more shut and drill pipe, okay, the more problem, the more mud weight you need to kill. And if this data is logic, it will give to you water, gas. But this is unknown because I'm putting random data. Okay, so maybe I put 50, maybe it gives something, you know. So this is the idea of kill sheet. However, it's in real situation, it tells you estimated influx time. But most important parameters in this, that one. Okay, you can inform, okay, because sometimes in this situation, rig manager asks tool pusher, please make kill sheet, okay, and he asks mud logging unit, please make kill sheet. Then compare each other, then he know how is the real mud weight I need to rise up to control the weight. This is the important, kill mud weight. Otherwise, the situation will not be clear. Okay? So weight control fundamentals is very interesting issue if you have some ability to get some manuals related to weight control, basics, not advanced. Read about what is the weight control methods. There is two methods, weight and weight, or the drilling method. What is the difference between this and this? So you have idea, it will give you more experience when you work in critical situation. Because you have tool, but if you don't know what all features the tool you have, so you didn't get most of benefit from it. So increase your information about this, because this situation may happen to you, okay? Okay. Data checking is just a secondary scale. You can just add any parameter, okay, and check what is the status. Is it? Yeah, it is. Is it this or is it? I don't get it some importance. So this something like alarm. Okay, if it's less than 50, he will inform. But please just check good parameter. Yeah. For me, I'm not using it. Yeah, he said to incorrect value Roman. Yeah, because I didn't put here good value. So I'm not working with this screen. You will not give it's important because you are controlling everything in your alarms. Here, alarm on off. No need to go there, a lot of work. Okay? Focus. Okay? And of course, cement job, if you have this type of sensor, you can get useful from it. Okay? But no. So this is running okay. This useful. This is not this is easy. Okay? Alright. Small things before we go to the break, because after the break I will answer the question to explain how to do in cement job, drilling cement, how to get the data. It should be known, and we will simulate some samples, okay, to study this screen. This is very important because also if you need to modify sample time, if you lost one sample, you need to adjust. Okay, this is very useful. After break, we will work with it. All right. Of course, these alerts coming from here, so I will delete. Okay, and save. For this screen, numeric screen for the pump, it's something showy. This is not going to viewers. Okay, it gives you separate data for the pump. Something for show. Okay, to check every output of the pump and something like this. But you cannot show it to viewers. This is only for your purpose. Okay, if you need to check specifically how much pump liter per second is getting to you, and this. Of course, if you have MATAX sensors, you will find all volumes here. You can evaluate if one sensor not working. Just go to here. Yeah, it gives minus value. I will check it. Yeah, something to help. Okay, but not depending on it mainly. And some main screens, this we know, this whole fixed screen, alarm, now we know the alarm, okay? Now we know how to mute and how to unmute the alarm, okay? This we studied yesterday, and after break, we go to lab data. But before break, we need to talk about the messages, the remarks, how to add remarks, how to work with remarks. If you need to type a comment, it will be shown to everyone. You just go here, add comment, and you have the ability to make two options. If you make it by time or by depth, corresponding to depth. So usually I'm using time, like this is time, pipe, pressure, okay, decreased gradually. Okay, for 4 bars. Then I would save. Once you save, it will give you that at that time you type this. Okay? If you need to add comment in early time, suppose not like now, it's half an hour ago. So up. So you just you forgot to add a comment and they will blame you. Okay? PVT, bed volume, the losses. Losses 5 cubic meter at 5 o'clock. Okay? I'm fine, I did it, but nobody see it. So something just funny, you know? Yeah, something funny. Of course, we have to add comments in suitable time. If somebody blame you, why you didn't put comment, you can. Okay? I'm complete. So these comments is saved in all viewers, and also you can yes, important this office for time logs and this thing. If you're producing time data logs every day, these comments is shown in time log also. In GeoOffice. No need to add comment for each operation. Because usually when I'm working in the rig or anybody, when you start drilling, I make a comment, start drilling right now. Okay? After we finish, they make survey. I type mix. Every operation, I put a lot of messages in the basic screen. So at the end of the day, I make the PDF not only curves, but messages up in the front of the curves. It comes from here. So you can produce 24-hour time data log PDF for drain parameter, for mud tanks with comments. No need to add again. Okay? So I need to make some modification. I make mistake. Here is your remarks screen. This is the remarks. that it's not 4 bars, it's 16 bar. So you can edit, you can edit because you did wrong, okay? And yeah, this is not legal, but okay, no problem. It's 16 bar, okay? So you are safe. I'm fine, okay? So nobody will blame you. To make again this. Okay? This is the remarks screen. So it's fixed. It's not shown. It's not shown in the viewer. Okay? Where is it? Remarks. Remarks screen. Okay? Everything is recorded by time. When you come to the unit, you need to see what happened in the shift before. Go to here, check. Yeah, operation is going. We always have pressure drop. We have partial losses. We have good information. It's logged. Okay. Yes, and by depths also, you just choose. Yeah, it's 4002 or 4001. Maybe, okay. Please make a comment like this. Okay, don't try it. Then save. So you will have here depths comments, time comments. Okay, by this way. So it's something simple. Okay. This is not shown here. Why? Because this is time screen. But in viewer, there is depth screen. It will be shown in depth screen because here the main scale factor is time. Okay, but usually we are working with times. All right. So can I go to comment for further? For further, let's try. It's a good idea. Yeah, maybe 5:30, no data, 3, 0, okay, okay, okay. No, not logic, so it not comes 6:30, 5:30, because no data is drawn. It will be fake, a lot of fakes, so no need. Okay? So usually we put comments on time. Okay? So you can add whatever you want. There is automatic messages comes, like samples. When sample come out, automatic message come on the screen. Sample number X is on the shaper and it's shown to everybody. Okay? If you make a reset for Matlo's game. Okay? Okay? So you reset, the parameter will be reset, and also one comment will be shown here to help the other people who is watching that Matlogger make reset now to calculate displacement. Something helpful like this. Okay? Yeah. And every reset here also will give you a message. If you need to reset strokes, yeah, I will reset strokes for counting bottom up, for bottom up counting. Okay? So you just put here and it's showing you total bump strokes counter is reset. Okay? Another way of reset, if I need to reset without message. I need to reset for myself. No need to inform everybody and make reset. Okay. Manual. Just go to your screen. Okay. If this is the strokes, this you need to reset. Okay. So just make. I'm making this manual 0. Save. Then please go again. Quickly. Computed. Save. Then it will no message now. It will not. Okay? Same Matlo's game. If you need to reset manually, same. Manual, zero computer. Yeah, so you have two options. Just the shortcut here gives message or manual no message. Okay? Yeah. So I hope everything is clear enough. If you need to discuss something, I can help. Okay? We can meet after the break. We can stay to discuss. No problem.
Có gì cần thảo luận về vấn đề này nữa không? Mấy cái kia nó cũng không cần thiết lắm.
Ok.
Ủa sao cái mức web mà nó không có hiện nó bị ảo lại?
Cái gì?
Web video của anh không bị ảo.
Cái nào?
Nó ẩn là này có rồi đó.
Cái chọn này là
Có
mình
cái manual mà. Lúc này nó chọn cái
Thì đó
làm chờ nó sửa đưa vào dập. Còn cái này nó đi ra kiếm rồi dập đi. Bên này mới tính toán ra.
cái này là dàn cung cấp có nghĩa là cái này là
cái này là không, cái này là cái áp suất bơm của nó, áp suất bơm thì nó là bao nhiêu, đúng không?
Nhưng mà mình đâu chia ra được.
Cái này nó ví dụ bơm 30 thì nó sắp xếp được bao nhiêu mà.
Thì đó, giờ nó bơm chung hai bơm mình đâu chia ra được.
thì không, có nghĩa là đây là nhập cái ấy, còn cái dưới này là nó sẽ tính chẳng hạn khi mà anh bơm tổng cả hai bơm bao nhiêu sẽ cấp thì để có cái áp suất đấy thì là nó sẽ tính ở đây cái gọi cái gì cái tối thiểu cái ở dưới này á, là áp suất cái này liquid test của nó là test của cây sinh này, nãy nó nhập nó lấy cái test của cây sinh, còn hai cái này á, là áp suất mà cái gì cái BOB của mình nhé, cái áp suất mà đối trọng BOB của mình ấy là nó có khả năng giới hạn của cái BOB á, là cái thông số của cái pin đấy đó thì nhập vào đấy để nó tính toán tiếp.
Thì cái này nó lúc test BOB là lấy cái đó.
Tất cả những cái thông số này là mình toàn là đi lấy của người ta về để mình tính
Mà cái này
không phải của mình.
cái này của
mình phải hiểu được cái thông
Thì
số
đấy thì
này.
mới bảo là cái những cái này là thiết bị của họ, từ cây sinh này rồi từ BOB này rồi các cái thiết bị an toàn của họ nó sẽ có những cái áp suất khác nhau.
Không gọi nó công tướng trạng rồi bảo nó tiền bạc.
Nó đòi hỏi từ chính họ
nói thì nói chứ mình phải anh không gọi không đưa nhiều ông sao biết được cái bây giờ anh phải biết được cần cái thông số nào.
Nói chung là nó sẽ có những cái minh giải đấy.
Thế bây giờ ông cho cái này đến ông mình chả biết cái này là cái gì thì
Đấy, mình không ai đi xài đâu, cũng
Cái bản không đưa cái gì đâu.
cái data check vừa nãy ông nói là làm